One of the toughest things to do is translate problems into equations. It's really important to know how to do this in order to pass the GED test. This is lesson 19C. There's links to 19A and B in the description and other helpful links. So to pass this test, we need to understand how to translate words from a problem into an equation. Now, in the description of this video, there's a link to my Algebra Word Problems playlist. It's about 130 something word problems in there. And I talk about clue words and writing equations. And if you watch all or as many of these videos as you can, you'll have a better chance of passing the GED test, okay? Because it'll really help you. So the first thing we need to do is identify the unknown amount and assign a variable to it. X and Y are used often, but we can really use any letter. We label the other amounts in the problem by how they relate to that x, to that variable. So if we have an amount and we need to take 3 away, it would be x minus 3. If we had 2 times the difference of a number and 3, we'd have 2 times x minus 3, see? We write an equation using that variable, and then we solve and check the answer to make sure we didn't miss something. You want to make sure you didn't accidentally miss something, okay? So here we've got a problem, and I've written it a couple of different ways, just to give you an example of what the variable can do. It says the cost of 3 triangles and $6 equals the cost of 5 triangles. So we have 3 triangles plus $6 is going to equal 5 triangles. Well, it's basically the same thing as saying 3t, if we use t for triangles, plus 6 equals 5t. We could even say 3x plus 6 equals 5x. See? We just use that same variable, okay? If you've been watching the previous videos, you know that we need to get these triangles to one side. So because there's 3 over here and 5 over here, let's take this 3 away, which means we have to take 3 away from this side because we have to keep it balanced. Then this creates a 0 pair and it eliminates itself. If you have 3 and you take 3 away, it's now 0. We drop this 6 down, and the dollar sign usually won't be in it. You just put it in at the end because it's talking about cost. I put it in there to help you. It normally would be written like this, and you just put the dollar sign in at the end. Because we took 3 triangles away from this side, we end up with 2 triangles. Now we divide both sides of the equal sign by this 2 coefficient. 2 divided by 2 is 1, so we have 1 triangle, and 6 divided by 2 is 3, so we know each triangle is $3. Same thing as if we did it with a t or an x as our variable. Same thing happens. We subtract the 3 from each side, or you could say we're adding a negative 3 to each side, and we end up with a 2t on this side, a 6 on this side. That created the 0 pair. We divide both sides by this coefficient 2. It's always divided by the one that's next to the variable because the whole idea is getting that variable alone. We end up with $3 equals t. All right? Okay, so this one says a store sold 7 more pairs of blue pants than gray pants. If they sold 23 pairs of pants, how many were gray? So we're going to let G equal gray pants. If the G equals gray pants and there were 7 more pairs of blue sold than gray, well then the gray pants plus 7 is going to equal the blue ones, isn't it? So G plus 7 equals blue and G equals gray. If we add these together, the G plus 7 for the blue pants and the G for the gray pants, it should equal 23. We combine the like terms. We have 2 G's here, so that's 2G plus 7. Now we can start getting it down so it's just a G. We can isolate that G, can't we? So we're going to take 7 away from both sides of the equation and create a 0 pair here. We end up with just 2G equals 16. We divide both sides by the coefficient 2, and we get 2 over 2 is the same numerator and denominator, so that's a 1, but we don't have to write the 1. We can see there's 1G there. And 16 divided by 2 is 8. We know that there were 8 gray sold, and we could even figure out if there were 8 gray sold, there must have been 15 blue sold. See? Process of elimination, we can figure out how many blue ones there were. It didn't ask for it, but we could still figure it out, couldn't we? Now, we could have gone the other way. We could have let B equal blue pants and solved it from the blue pants point of view. I chose G for gray. So if we let B equal the blue pants, then that means blue pants minus 7 equals gray, because there were 7 more blue. So if we take that 7 away from the blue, we'll have the gray ones, won't we? So now we have B for blue pants and B minus 7 for gray pants. Now we're just going to solve for B. So here's our gray pants, here's our blue pants, and they total 23. We combine the like terms. We have 2 B's. So we have 2B minus 7 equals 23. So now because we have a minus 7, we can add 7 to both sides of the equal sign to create a 0 pair here and eliminate it. We end up with 2B equals 30. 23 plus 7 equals 30. And we divide both sides by this coefficient 2 to get the B by itself. And we end up with 1B equals 15. So see, there were 15 blue ones sold. And we can take that away from the 23 and see there's 8 gray. See? Now, many GED math problems are setup problems. Instead of actually solving these, we need to choose the correct equation. So take a look at this one. It says Saturday's sales were $250 less than twice Monday's sales. Wow, you have to read that a couple times, right? Total sales for both days was $887. So which equation would find Monday's sales? So we're going to let the M equal Monday. We could use an X, but when I do these problems, I find it easier to use the letter that actually tells me what I'm looking for. I'm looking for Monday's sales, so I'm going to let M equal Monday. I'm going to solve for M, see? So here's our choices. Which one of these equations fits this word problem? They all look so alike, don't they? But you have to look at them very carefully. This one says plus 250 plus M. This one says minus 250 plus M. This is a plus and then a minus. This is a minus and a minus. And this is adding 2M plus 2M minus 250. See? So they are all different. We just need to figure out which one is the correct one. So if Saturday was 250 less, that means we're going to have a minus 250, right? So it won't be this one because that's a plus 250, and it won't be 3 because that's a plus 250. So it's going to be 2, 4, or 5. So just through process of elimination, we can say it's not this one and it's not this one. That'll help you when you're taking the test. Get rid of the ones that you know it's not. If Saturday was 250 less than twice Mondays, that means we need to multiply the Monday times 2, don't we? There's going to be 2 Mondays. So which one of these has 2 Mondays? Well, they all have a 2M, don't they? So that didn't really help us. So we have to look at this further. It was 250 less than twice Monday's sales. So if Saturday is 250 less than twice Monday, that means we have 2M minus 250. It's 250 less than twice Monday. See? So now we've got 2M minus 250. So it can't be this one. So we know it's not number 5. So now we've got it down to it's either 2 or 4. It's one of those, okay? Now it says they both equal 887. So we're going to have to add the 2M minus 250 that represents Saturday and the M that represents Monday. So if we're adding this M to equal 887, well, then it's not number 4 either, is it? Because that's subtracting M. Now we know it's number 2. We have 2M minus 250 plus M equals 887. Now, that's the end of the problem. It tells you, go on to the next problem. You found the equation that fits. But I'm going to help you out and we're going to solve this, okay? Because we have a 2M here and an M here, we can combine them. They're like terms, and we can have a 3M. Now we're going to take away this 250, and this 3M minus 250 should equal 887. All right? So even if there's no parentheses here, you can still see that there's 3 M's, aren't there? And the 3 M's are going to take away a 250. So we can take this 250 right here, this negative 250, and add 250 to both sides of the equation. That'll create a zero pair here. Minus 250 plus 250 makes a 0. So we eliminate it. Now we have 3m equals 1,137 because we added those together, see? Now we have 3m equals 1,137. We divide both sides by this 3 coefficient right here. That creates 1m, and quickly on your calculator, you can do 1137 divided by 3 and get 379. That means Monday's sales were $379. We can actually figure out Saturday's sales by subtracting it from the 887, couldn't we? To see what's left over, that would be the Saturday ones, all right? Now take a look at this. It says 15 times a number divided by 5 equals 3 times that number. So I broke it down into very small parts. 15 times a number, well, that's 15n. We could use 15x. Divided by 5, well, I always say fractions are little division problems. So now we have 15n divided by 5, written like this. And it says it equals 3 times that number. So it's going to equal 3 times that variable, n. See? This one says Tala is 4 years older than Eva. 2 years from now, Tala will be twice as old as Eva. How old is Eva now? So take a look at this very carefully. We're solving for Eva. So we're going to let E equal Eva's age now. That's going to help our brain, okay? Because we know we're going for the E for Eva, not T for Tala. So we have to put everything in relation to Eva, all right? So if Tala is 4 years older than her, then Eva is 4 years younger than her. See? If she's 4 years older, then Eva is 4 years younger than Tala. That makes sense, right? Think about that. So we're going to let Eva be E. That's her age now. We're also going to let E plus 4 equal Tala's age now. Eva is 4 years younger, Tala is 4 years older. So if we have Eva plus 4 years, that will be Tala's age now, right? If we add 2 years, it says 2 years from now. If we add those 2 years from now, then Eva is going to be E plus 2, because she's E, so she'll be E plus 2. And Tala will be E plus 4 plus that 2 years, see? Now, our equation says E plus 4 plus 2, that's Tala's age, is equal to 2 times E plus 2. Because we're talking about 2 years from now that Tala will be twice as old. So if Eva is E plus 2, if she's twice as old, it'll be 2 times E plus 2, wouldn't it? So now, when we use distributive property on this side, for the parentheses, we get 2e plus 2 times 2 is 4. So now, and we combined the 4 plus 2 to get a 6. See that? So now we've got e plus 6 equals 2e plus 4. We can add a negative 4 to both sides of the equation because we want to isolate the e by itself. And that'll create a 0 pair here, so we don't have anything. Plus 4 minus 4 is 0. And when we take away 4 from the 6, we get a 2. So now this e drops down. We have e plus 2 equals 2e. We still need to get all the e's to one side of the equal sign. So if we take away the e from this side, we have to take away an e from this side. Remember, there's an invisible 1 in front of this variable e. So this creates a 0 pair, and this is gone. We just have a 2 equals a 1e, but we don't have to write that 1, do we? We just have 2 equals e. So we know that Eva is only 2 years old now. See? Now, I know this can be really confusing. If you have to watch this part of the video again, well, no biggie. You need to understand how to get these into equations, all right? There's actually questions like this on the test. Here's another one. The number of dogs at the shelter is 12 fewer than twice the number of cats. So we're going to use C for cats. If there's 60 dogs and cats combined, how many cats are there? So we're going to solve for C. We're going to solve for cats. So I'm going to let the C equal cats, and because there's 12 fewer than twice the cats, 12 fewer is minus 12, right? That's 12 fewer. Then twice the cats, so it's 2 times cats. So we have 2C minus 12. That would be twice the cats minus 12. That's what the dogs equal. See? Now, we know combined it's 60. So we know that 2C minus 12, that's the dogs, plus C for cats is going to equal 60. We can combine the like terms. We have 2C and a 1C here. That makes a 3C. We bring the minus 12 down, and we've got 3C minus 12 equals 60. We need to get the C to one side of the equation, and it's already on one side, so we just need to get it by itself. So we need to get rid of this minus 12, so we can add 12 to both sides, create a 0 pair here, and that eliminates it, and we end up with just a 3C coming down, and we add 60 plus 12 and get a 72. We divide both sides of the equation by this coefficient 3 next to the variable. That creates a 1C, and 72 divided by 3 is 24. We know there's 24 cats. So you might see it on the test say which equation fits this problem, and it could be written like this, or it could have already combined the like terms and it might be written like this. So look at it very carefully, okay? If you see it written like this, well, then that makes sense, right? But if you see it written like this, say, well, what happened here? Oh, they combine like terms. It might even be written as 3C equals, it could also be written as 3C equals 60 plus 12. That could be another way of writing this, because when we drop this down, this 3C, it could be 60 plus 12 instead of 72, see? So it can be written in more than one way, so we have to be careful. And we can figure out if there's a total of 60 and 24 cats, we can figure out how many dogs there are, can't we? Just by doing some subtraction. So here's some phrases. We have 3 more than twice a number. Well, if we have 3 more, it's plus 3, isn't it? Or 3 plus. And twice a number would be 2x or 2n or whatever variable we choose. So we have 3 plus 2x. We can also say 2x plus 3. It doesn't matter which one's first because it's addition. Okay? It only matters when there's subtraction. This one says 5 times the difference of a number and 2. So if you break this apart into a couple of parts, we've got 5 times, and we've got the difference of a number and 2. And the difference of a number and 2 is x minus 2. That's the number minus 2. But we have 5 times it, so it's outside parentheses. We've got 5 times x minus 2, see? We would distribute that, wouldn't we? We'd have 5x minus 10. All right. This one says for more than the quotient of a number and 2. So 4 more would be 4 plus, and the quotient of a number and 2 would be x divided by 2. It's a number and 2, we get its quotient, see? And because it's addition, we can also say x divided by 2 plus 4. Either way, it's going to be correct. This one says 3 times the sum of a number and 4. So again, we can split this apart. 3 times sum of a number and 4. And the sum of a number and 4 is x plus 4. 3 times it would be 3, then parentheses, x plus 4, close parentheses. And we could distribute this, couldn't we? We can say 3x plus 12. See? Now, you should be ready to do the skill focus on page 225, but what I do want to say to you is, to pass this GED math test, what's really important is knowing how to change words into equations and understanding how to read graphs. If you can do those 2 things very well, you should have a very likely chance of passing the test, all right? And we're going to be talking about actually solving algebraic equations in the next video. We're going to do some more of this, but I have that algebra word problems playlist with like 137, I think, videos in there. And the first 10 are phenomenal because I talk about the clue words and how to turn the words into actual equations. And there's going to be all these links to these helpful videos, all right? Going all the way up to the beginning of Algebra 2 even. So if you can write these down and watch these blue ones, and most definitely do your best to try to watch this playlist here and the previous videos for this lesson, because these are all connected. I build upon each lesson, all right? So I hope you do well. Take your time and watch this video again if you have to, and watch that algebra word problem playlist, because that is going to be a key to success. You have to understand word problems. There's so many of them on this test. And if you can go through this playlist and just keep watching one video after another and take notes if you have to, I think you'll do very well, okay? I'll see you next video. Bye.